Welcome. This is Coach Dorf. We're in section 1.5, and we're going to look at an example of a homework problem. So this problem has two parts. Solve the following for x. And the first one is the natural log of x plus the natural log of parentheses x minus 1 equals 0. We want to solve that for x. And the second one, we have e to the power 1 minus 2x equals 9. In both of these problems, we're going to use the facts that the natural log of e to the x equals x, and the fact that e to the natural log of x equals x. Those are going to be two properties that will help us solve these problems. All right, so let's look at part A. I have the natural log of x plus the natural log of x minus 1 equals 0. First thing I would do is I want to combine these log terms on the left side together. And I'm going to use a property of logs that says if I have the log of something plus the log of something else, then I can write that as one log function by multiplying those two terms together. So on the left-hand side, I'm going to get the natural log of the quantity x times x minus 1. And the right side stays the same. Now, I want to get rid of that log on the left side. So to do that, I'm going to use the second property that I just wrote above, that e to the natural log of x equals x. So I'm going to take e and I'm going to put it to the power of what I have here on the left side. And since I'm doing that to the left side, I have to do the same thing to the right. So I take e and I put it to the 0 power. So by that property above here, by this property here, I'm going to apply that right here. What I now get is x times x minus 1. The e and the natural log undo each other. And on the right side, I get e to the 0, and e to the 0 is just 1. So that looks a lot nicer to me. I'm going to go ahead and multiply on the left side through by the x. So I'm going to get x times x to get x squared, x times a negative 1 to get negative x, and that equals 1. Now I'm going to bring everything over to the left-hand side so that I get a 0 on the other side. So I get x squared minus x minus 1 equals 0. At this point, you could try factoring the left-hand side. And that's like writing two double parentheses and trying to figure out what that factors to. This one doesn't factor very easily. And so it's better, I think, at this point to go ahead and use to use the quadratic formula. So let's just review here the quadratic formula. Quadratic formula says that if I have something that's ax squared plus bx plus c, and that equals 0, then x is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So for our problem here, we have, I'm going to write the problem down again. It's x squared minus x minus 1 equals 0. So we have a equals 1, b equals negative 1, and c equals negative 1. So using the quadratic formula, x is going to equal negative b, so minus a negative 1, plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. And if I simplify that, I get 1 plus or minus 1 plus 4 all over 2, or I could write that as 1 plus or minus square root of 5 over 2. Now, I need to check that my answer is reasonable. This gives me two answers, right? This means that I have either x is 1 plus square root of 5 over 2, or x is 1 minus square root of 5 over 2. Are both of these reasonable answers to this problem? Well, it turns out the answer is no. One of these is not correct. Which one is not correct? Turns out I can't use this second one. Why not? Well, if x were 1 minus square root of 5 over 2, the value of that turns out to be a negative number. This is a negative number. I don't know off the top of my head what it is, but I know it's a negative number because the square root of 5 is larger than 2. So when I do 1 minus the square root of 5, I'm going to get 1 minus a number larger than 2. I'm going to get a negative number there. And why can I not have an x be a negative number? Well, if I go back to the original problem, was the natural log of x plus the natural log of x minus 1 equals 0. And recall the domain for log functions is, if I have something like this part right there, has to be greater than 0. It can't be negative and it can't be 0. Well, if I had x equal 1 minus square root of 5 over 2, and I substituted it into this equation here, I would get something that's not in the domain. I couldn't put x equal 1 minus square root of 5 over 2 into the log of x because that x value is negative and that's not in the domain. So that's why that's not a possible answer. So the final answer is x equals 1 plus square root of 5 over 2. So important to remember what works for your domain. So that was part A. Part B, we have this equation, e to the 1 minus 2x equals 9. Now we're going to use that other property that was mentioned above, which is that if I have the log of e to the x, that equals x. All right, so I'm going to apply that. I'm going to take the log of both sides here. So I have the log of e to the 1 minus 2x equals the log of 9. So I now have, by that property, I can write down that this is 1 minus 2 to the x. Now, if you forget the property, another way to think about this is that with the logs, I can bring this part out front. So another way of thinking about this is 1 minus 2x times the natural log of e equals natural log of 9. Either way, I'm going to bring that out front. And this is an important idea that anytime if you have a problem where you have the variable is an exponent and you want to bring it down so you can solve for it, applying a log to that function allows you to bring the exponent up front and bring it down to the main base. So again, anytime if you have something like e to the x and you want to bring that x out front, let's say we had this e to the x equals 4, I'm going to take the natural log of both sides, and by the properties of logs, I can bring that x out front, and I have x times natural log of e equals natural log of 4, and the natural log of e is 1. And so I just get x equals natural log of 4. So that's a really useful technique here. Going back to our problem here now, we have 1 minus 2 to the x. The natural log of e is 1. So we have 1 minus 2 to the x equals natural log of 9. I'm going to solve for x. So I'm going to subtract 1 from both sides. So I get negative 2x equals minus 1 plus natural log of 9. And now I'm going to bring that negative 2 over. So I can do that either by dividing by negative 2 or multiplying by negative 1/2. Either way, I'm going to get 1/2 here minus 1/2 natural log of 9. Now you could stop here, but you could also notice that this 1/2 I have up here, I could apply that to this log here. And in that case, I get x equals 1/2 minus the natural log of 9 to the 1/2 power. And what is 9 to the 1/2 power? Well, if I do that before I apply the log, 9 to the 1/2 is the square root of 9. So that is 1/2 minus the natural log of 3, because 9 to the 1/2 is the same thing as the square root of 9, which is 3 there. All right, and so that then becomes my answer. Hope that helps you. Thanks.